Hello everyone and welcome back to my channel Gyan Sampada. In our previous class we had a discussion on line width correction where we have derived in detail and overcome the limitation of basic principle of paramagnetic resonance. So if you have not gone through it, you can check the playlist section named Magnetic Resonance. And today we are going to continue with the same topic where mainly we will be dealing with the application part, which helps us in understanding two different approaches to study these magnetic resonance phenomena. And today our concept will be entirely based on ESR or EPR, that is electron spin resonance. So before moving to it, let us understand some details about resonance phenomena which we are discussing from few classes. So resonance means something there should be a maxima or energy absorbed will be maximum. So the interaction of electromagnetic radiation with matter gives rise to different types of resonance phenomena or resonance spectroscopy. And based on the type of radiation absorbed by the matter or interacted with the matter, we can divide the resonance phenomena or resonance spectroscopy into mainly two types. First one is NMR spectroscopy, which is nuclear magnetic resonance spectroscopy. So here the absorption of electromagnetic radiation by matter will be lying in radio frequency region. And the second type is ESR spectroscopy, that is electron spin resonance spectroscopy, and here the absorption of electromagnetic radiation by matter will lie in microwave frequency range of the electromagnetic spectrum. So based on the type of radiation absorbed, mainly we are having NMR and ESR spectroscopy. And today we are going to deal with ESR spectroscopy in detail. So what actually is ESR spectroscopy, what are different things or working mechanism, the application, everything will be our today's class. So this ESR is also called as EPR or EMR. So ESR means electron spin resonance or EPR is electron paramagnetic resonance and EMR is nothing but electron magnetic resonance. All these things mean the same. So why they are having different names, we will get to know when we just go through this class today. If we want to know about the history of this ESR, then this phenomena was first introduced by the Russian physicist Vyazovsky in the year 1944 by applying 47.6 GHz of frequency using copper salt. So copper salt was taken and to that salt frequency of 47.6 GHz was applied and the response was studied. And the basic principle of ESR spectroscopy is closely related to the NMR spectroscopy, but as such the application and instrumentation is quite different. So if you have a clear idea about ESR, then easily NMR can be understood. So just to move on to the definition part of ESR, we can say that ESR spectroscopy is a branch of absorption spectroscopy, because main phenomena here taking place is absorption of energy, in which the radiation having frequency in microwave region is absorbed by the paramagnetic substance to induce transition between magnetic energy level of the electron with the unpaired spin. So main factors you need to remember while defining ESR is it is an absorption spectroscopy branch where the absorption is taking place in microwave region by a paramagnetic substance. So this phenomena is observed in paramagnetic substances only, due to which it is also called as EPR, that is electron paramagnetic resonance. And also the absorption has to take place means there should be the transition between magnetic energy levels of electron with the unpaired spin. So there is the influence of magnetic field which is going to influence the spin of the electron, and by the absorption of microwave energy by the paramagnetic substance, we can study electron spin resonance. So microwave frequency range means in general we can say it is 10 raised to 8 to 10 raised to 11 hertz. So this is just the introduction, and the main part is the application part of ESR. So we need to know what is the application of this methodology. And ESR is a powerful tool or technique which helps us in studying about the free radicals, means the atoms, molecules or ions containing one unpaired electron either in solid, liquid or even in gaseous form. Second, in order to study the transition ions as well as the actinide ions. So these have up to 5 or 7 unpaired electrons, and in order to study those also ESR is helpful. And moving to the third is to study the various point defects in solids. So it may be the delocalized imperfections, these also can be studied using ESR. And also we can find out whether the system is having more than one unpaired electron or no, like the triplet state systems, the biradicals and also the multiradicals. And another important thing is we can study the system with conducting electrons like your semiconductors and metals. So mainly these are the applications where ESR works as a powerful tool in studying different properties in different types of materials which will be having the unpaired electrons. Then moving to the limitation, by the name itself we can say that it is applicable only for paramagnetic substances. So we cannot study this for diamagnetic substances. So this can be a limitation of ESR or EPR. So then let's understand how actually the working takes place. What actually is the working principle behind ESR? So if we consider an atom, we know that atom consists of a positive core, that is the nucleus, and the electron will be revolving around the nucleus. But we shouldn't forget that the electron not only just revolves around the nucleus or the proton, it also rotates with respect to its own axis. And we know that whenever a charged body rotates, it is going to produce magnetic field. That is, here the electron is the charged particle and electron is rotating means electron behaves like a magnet. And the magnetic field generated due to the rotation of electron about its own axis mainly gives rise to two properties, or we can understand about two different properties. First one is diamagnetism and second one is paramagnetism. Here two properties means two behavioral response of the material based on which the nature or the characteristic of a material can be understood, whether it is para or diamagnetic. How? Let us study now. So clearly we can differentiate between diamagnetic and paramagnetic substances. So if we are going to consider diamagnetic substances, we know that in diamagnetic substances the molecules contain paired electrons. That is, it has even number of electrons. So that can be visualized here. So one electron is rotating in clockwise direction, another electron is rotating in anti-clockwise direction. So we can say that here the spin quantum number is plus half, here the spin quantum number is minus half. Plus half corresponds to clockwise rotation and minus half corresponds to anti-clockwise direction. So here we can observe there is an antiparallel magnetic field which will be due to these paired electrons. So one is spin up, one is spin down. So finally we can say they will cancel out their contribution. And on the another hand, if we are going to consider for paramagnetic substances, we say that the molecules contain unpaired electrons, means odd number of electrons. Or if we want to find out whether the material is paramagnetic or diamagnetic, if unpaired electrons are present, then we can say that the molecule can exhibit paramagnetism. So here the paid electrons, whichever will be there, they are going to cancel out their contribution, whereas the extra electron which will not be paid, that is going to contribute for such property. So the next difference we can clearly say that here the magnetic field will be self-cancelled because of the opposite rotation of the electron, whereas here no self-cancellation will take place due to the extra electron which is unpaid. So whichever paid electrons will be present in the paramagnetic material, they are going to cancel out their contribution, whereas the unpaid electron will contribute for this property. And for example, we can say hydrogen, bismuth, etc. are diamagnetic, whereas paramagnetism can be observed in free radicals, metals, triplet state of electron, etc. So we can say that electron paramagnetic resonance is a sophisticated spectroscopic technique which is going to detect the free radicals in your chemical or biological systems. And this is just a branch of magnetic resonance spectroscopy which is going to utilize the microwave radiation to probe the species with unpaired electrons like the radicals, means the radical cations or the triplets, in the presence of an externally applied static magnetic field. So one is magnetic field which is applied, then the microwave radiation, finally giving rise to the resonance phenomena. So this is the introduction or the working principle based on which we can distinguish between two different types of materials. And now, in order to visualize how it actually works, let us make use of some diagrams so that visualization becomes easier. For that, let us consider a ESR chamber where all this phenomena is going to take place. So in this chamber, an unpaired electron molecule is kept, and let us say it is rotating in anti-clockwise direction. So we are having a unpaired electron, which is the first criteria for paramagnetic resonance to take place. So don't think that only a single electron will be inserted within the chamber. We are going to introduce a molecule which will be having a unpaired electron. It may be one or more than one unpaired electron. And to the system, we are going to apply magnetic field. So if we need magnetic field, then we need a magnet. So to this ESR chamber, we are connecting a magnet. Generally the strength will be from 50 to 500 millitesla or even like 3400 Gauss. So as such, electron, we know that it is spinning with respect to its own axis. So due to the rotation of the electron, already the magnetic field will be produced. That is, the electron itself is acting as a small magnet. And now to that we are again applying a magnetic field of certain strength, and that magnetic field will be acting in downward direction. So this shows the direction of magnetic field which is applied, and due to this applied magnetic field, the electron spin will reorient. That is, the spin of the electron will try to orient along the direction of magnetic field. So the direction of electron spin and the applied magnetic field will be same, and such system is known as alpha state, where we observe the spin and applied magnetic field direction as parallel, and we say that it is a lower energy state. So now to this alpha state, we are going to incident a microwave radiation. So already magnetic field is there, and then photon is incident which has the frequency of microwave region. So when the electron interacts with this photon, the energy of the photon will be absorbed by the electron, and due to the absorption of electron, the spin of the electron will be flipped. That is, earlier it was in the direction of the magnetic field. After absorbing the energy from the photon, it will change its direction to the opposite. That is, now the direction of the magnetic field and the electron spin is going to be opposites. So clearly, spin of electron is in upward direction and magnetic field applied in downward direction. So here we can observe that flipping of the electron spin is going to take place due to the effect of the incident photon, and this state where we observe antiparallel nature, that is, due to this incidence of photon on the electron, this electron is able to oppose the applied magnetic field and orient in opposite direction due to the absorption, which is called as beta state or even called as antiparallel state. And due to this type of orientation, we get a higher energy, due to which it is also called as higher energy state. And we should remember that energy in the form of radiation is applied to the alpha state to get the beta state, and the microwave radiation of approximately 3 centimeter or 9 gigahertz is enough for this. And this shift or change in the direction of the spinning of electron gives rise to resonance phenomena. That is, we can observe that energy absorption is maximum. And whenever energy absorption is maximum, we remember the peak. Even we have studied under cyclotron resonance, when frequency is equals to omega c, cyclotron frequency, then absorption will be maximum. And here, when there is a transition or shift from alpha state to beta state, we say that absorption of energy is maximum, which is nothing but resonance. So everywhere magnetic field is involved, that is the magnetic field due to the electron spin as well as the external magnetic field which is applied, and finally resonance takes place, due to which it is also named as electron magnetic resonance and electron spin resonance, because here the spins of electrons are involved, that's why ESR, that is electron spin resonance, and it is only possible for paramagnetic substances, due to which it is called as EPR, that is electron paramagnetic resonance. So these are the three namings of the same phenomena. So paramagnetic means odd number of electrons. And let us say we are going to block the electromagnetic radiation, that is, now we will just stop incidenting the photons. So in that case, when the microwave radiation is blocked, then the beta state comes back to alpha state. So again, there we can observe flipping up of the electron spin. So this process goes on with respect to incidenting a photon and blocking of the photon. So energy absorption simultaneously takes place. So based on the absorbed amount of energy, different physical properties of different type of paramagnetic substances can be understood. That is, the system which has unpaired number of electrons can be studied. So just to sum it up, we can say that an unpaired electron molecule is taken and it has its own magnetic field, then we are applying an external magnetic field, then the spin of the electron is going to orient with respect to direction of magnetic field, and such system is called as alpha state, which is also called as parallel state or lower energy state. And to this alpha state we are going to incident the microwave radiation of 3 centimeter or 3 gigahertz, that is the frequency, and the electron spin is going to absorb this energy and it is going to flip, where the spin direction will be opposite to direction of the applied magnetic field, which is called as beta state or also called as antiparallel state or higher energy state. And this is what is going to explain us about the resonance, where the absorption of energy is maximum. And again, if we just block the electromagnetic radiation, that is microwave radiation, we get back the alpha state itself. So this is how electron spin resonance technique works, and generally inorganic compounds and the solid form of compounds are used in ESR studies. So generally we will know what about the crystal structure of any given sample, and based on the absorption data or the resonance spectrum, easily we can understand whether there is a defect or which type of arrangement is there or how many number of unpaired electrons are present within the given material. So this is about ESR spectroscopy, where main thing is the magnetic field, the unpaired electron and the interaction of microwave radiation. So if we have understood about the ESR or EPR, then studying about NMR will be very easy because principle, working, everything is same. Only the instrumentation and the application will vary in case of NMR spectroscopy. And this is for today's class. See you in our next class for discussion of NMR spectroscopy. Till then, study well, practice more, and thank you for watching.